guys. So our Cornell notes for this presentation, the EQ is to investigate the evidence of evolution. And the objective, we're just going to put our unit down. This is Unit 4. Investigate the evidence of evolution. And it is Unit 4. Go ahead and get that down on your Cornell note template. Investigate evidence of evolution, and this is Unit 4. Give me a fist of 5 on having those two things down. Are we good? All right, we're going to move on. All right. First heading in your left-hand column, I want you to put evidence of evolution. First heading in your left-hand column, I want you to put evidence of evolution. On the right-hand side, you're going to put evidence, common ancestry from many sources. The evidence of common ancestry is from many sources. We're going to list 4 here: fossil record, geographical distribution, comparative anatomy, and molecular and genetic evidence. Left-hand column, evidence of evolution. Right-hand column, evidence, common ancestry, many sources. And then we're going to list these 4. And then in a moment, we're going to dig into each of these. They are the fossil record, geographical distribution, which you should have learned about last year when you talked about plate tectonics, comparative anatomy, and molecular and genetic evidence. Remember, smarter, not harder. Abbreviate where you can. All right, moving on. Common ancestry, what is it? So left-hand column, you're going to put the term common ancestry. So new heading, new ink. Change your pen. Common ancestry is a group, related species. They come from same ancestor. A group of related species that come from the same ancestor. And examples here would be like a tiger and a lion. Like you can tell they've got a lot in common, right? But are they identical? No. Common ancestry, group of related species from the same ancestor. All right. Fist to 5, are we in good shape? That wasn't a whole lot to write. Okay. New heading, new ink, left-hand column. This one is fossil evidence. Fossil evidence. On the right-hand side, fossils record species long ago. The fossil record is a collection of fossils in order. It shows history of life. And these fossils are preserved in rock layers. So would my oldest fossils be closest to the surface or deepest in the ground? Yeah, they'd have to be deepest in the ground. That kind of just makes sense, right? They were buried a long time ago. Fossils record species long ago. Fossil record is a collection of fossils. The order shows the history of life. Fossils record species long ago. Fossil record is the collection of fossils. The order shows the history of life. And if you think you'll forget, you can always say deepest equals oldest. If you think that that's going to help you. All right, moving on. Does anyone need me to wait, or are we good? We're good? Wait a second? Okay. New heading, new ink. This is really kind of what I mean when I say deepest or oldest. New heading, left-hand column is the law of superposition. Again, this is a concept that's usually introduced in 8th grade. It estimates the time during which an organism lived, compares the placement of fossils in rock, and then it's where we get relative age. So a given fossil is younger or older than what is below or above it. So if it's shallow, so it's not deep, it's younger, right? If it's deep, it's older. If it's shallow, it's a younger fossil. If it's deep, it's an older fossil. When you're done, show me you're done by standing to your feet. go ahead and stand up to get what you need. All right, here's your orders. You've got like a minute and a half. You must walk over to the orange table, do 2 circles around it, 2 laps, find one person to high five, and go back to your seat now. Go walk 2 circles around the orange table, high five one person, and go back to your desk. That's a great question. Yes, he's got 2 last names, and I have to look.
Is it not Cortez but Martinez?
I think it's Martinez. Let's walk a little faster. Y'all are slowpokes. 2 circles, high five, and back to your seat. Miss Neighbors, do you see this? Yay! High fives. All right, let's go. Okay. F will be 1, G will be 2, H will be 3, J will be 4. When I read this question, think about your answer. You're going to hold up what you think the correct answer is with your fingers. When multiple transitional fossils are found in many rock layers, they provide evidence of 1. Seasonal variation in the diet of a species. 2. Gradual change in a species over time. 3. DNA functioning as the genetic material in organisms. Or 4. An unchanging environment. Multiple transitional fossils are found in many rock layers. They provide evidence of hold it high. I'm seeing several people haven't made a decision. Waiting on Ryan. And Joel. And Terrence. All right, if you chose 2, good job. It is 2. All right. New heading in your Cornell notes, I want you to put the term gradualism on the left-hand column. Gradualism.
Because I saw it on the test and I was like, oh.
Wait a minute. Gradualism is slow and steady change of one species into another. It is over time. Gradualism, slow and steady change of one species into another. This happens over time. Once you're done with that, you'll get a new heading and a new ink, and you're going to do punctuated equilibrium. These are long periods with little change, interrupted by short period of rapid change. So it's like, nothing's happening. This is boring. Bam! Something really big happened. And then we're back to nothing's happening. This is boring. This is usually due to sudden environmental change. For example, there was an explosion in mammal diversity after the dinosaurs died. Why would that be? There's no more predators. Yeah, they have more food and less predators. Bless you. So gradualism, slow and steady change of one species into another. This is over time. Punctuated equilibrium, long periods of little change interrupted by shorter periods of rapid change. This one's due to sudden environmental change. For example, the dinosaurs going extinct. You all right? Uh-oh. Equilibrium. It means balance. Give me a fist of 5 on this. How many minutes do you need? You need 2, maybe 3? Who else? 2? Okay. All right. Should be wrapping it up. Due to sudden environmental change. All right, again, A is going to be 1, 2, 3, and 4. Here's your question. Certain species of the coral-like sea organisms called bryozoans first appeared about 140 million years ago. They remained unchanged for the first 40 million years and then suddenly experienced rapid genetic change. Which process would best account for the pattern of evolution? Read your options and then show me what you think the answer is. Is it 1, convergent evolution? 2, differentiation? 3, punctuated equilibrium? Or 4, gradualism? Choose your answer now. I have 4 people, 5, 6 people who have chosen an answer. You literally just wrote it down in your notes. The answer is 3. Very good. All right. New heading, new ink. Left-hand column. We've still got like 5 minutes. 7, really. New heading is biogeography. Biogeography, left-hand column. This is the distribution of species. It's explained by continental drift of plates and speciation. Many related species occur across the world. So when you put all the plates back together as they would have been when Pangea existed, okay, you can see bands of like species that stretch across every continent, even though those continents are no longer connected. This is biogeography. So let's say I had an animal that could be found in all of those regions. And then I have another animal that can be found in all of these regions. Then I have another animal that can be found in all of these regions. Well, that means that those regions had to have been connected before, even though they are now separated by water. And we can see this evidence in our fossil record. And it looks like I drew a loaf of bread across the world.
Oh, we have possums.
Yeah. Kangaroos and possums kangaroos in Australia.
Possums are the only marsupials in the United States.
There you go. There's the connection. Thank you. Did y'all know that possums are marsupials? Do you know what it means to be a marsupial? What do they have?
Eat trash.
A pouch. Their infants, once they're born, live in a pouch for a period of time before they're actually independent out on their own. Well, kangaroos do this, so do possums. We have possums here. We don't have kangaroos here. But obviously, there must be some sort of common ancestor, right? No, they're born normally and then crawl to the pouch. Mm-mm. All right, fist of 5 on this. How are we doing? What slide are we on? All right, we're going to go ahead and stop here for today. We've only got 4 minutes. I need you to go ahead and pack up and clean up all of your supplies.